All right, 10 o'clock. Welcome, everybody. My name is Bobby Henderson. I work with Long in our hydronics and plumbing department. Welcome to another installment of Long's Coffee Break series. So if you're new to our Coffee Break series, just a quick rundown. This is a quick 15-minute product presentation. We don't do any sort of Q&A, so please direct all your questions to your Long salesperson. So without further ado, I'm very excited to introduce Bob Ellis. He is our regional sales manager for Raypak. And today he is going to talk about what I think is a really important topic in today's condensing boiler world, which is maintaining proper water flow through our condensing boilers. So without, like I said, further ado, Bob Ellis, please go ahead and take it away, Bob.
Well, doggone it, could you check that out? My brother Brian is on the line. So, howdy, Brian. Hey, how much is enough, guys? I mean, as far as when we're talking about flowing through condensing, the newer condensing boilers in particular, and in particular, we're really we're going to have more of a discussion on the stainless products, because that's kind of what's been really going through the market today. You notice that there's all types of different boiler types and materials that have been on the market, that are currently on the market, from the lower efficiency copper fin tube, cast iron, steel tubes. You know, they could be fire tube, water tube, could be cast iron, or could be cast aluminum, stainless steel vertical fire tube, stainless steel water tube. I mean, there's just a whole myriad of different types. But the ones that are really catching on strong are the stainless steel condensing. And the primary reason for that is because they are the best at managing the byproducts of combustion, you know, as far as the condensate goes, and really truly condensing a boiler. So this right over here on the left is a water tube, and we know that that is flow dependent. Otherwise, we're going to boil water in the tubes. We'll get a leak because we're going to fatigue the material, because there's no flow going through it. The heat just is staying in the material. Over on the right side here, we have a fire tube, and that's all. This is a big tank with fire tubes going through it that's vertically firing downward, all water backed up along the top combustion chamber. They are very different than the prior fire tubes of yesteryear, as far as being steel tube, fire tube type of boiler, or a cast iron type of a unit, because they don't handle low flow conditions as their prior predecessors did, the lower efficiency type units, primarily because of material. So when we're looking at different materials, notice I mentioned there was copper fin tube, there's an aluminum, cast aluminum boiler, there's steel tube. You'll notice how the efficiencies lay out in the materials and why they're used. Copper is used obviously because it's the best heat transfer material that is commonly used in heat transfer in boilers, but it does not handle the ultra high efficiency conditions, you know, condensing conditions. It'll eat the material up. Aluminum can handle it somewhat, but it also has challenges, and so does, of course, iron. But stainless steel, having the least heat, being the least in its heat transfer characteristics, in its properties, it, believe it or not, handles, of course, the condensation very well. But there's a downside to it. If you don't keep the flow going through that good heat transfer, you are going to have problems with the material, and that's pretty common throughout the industry today. So if you look at different flow rates through a heat exchanger, and this is showing a water tube example, and I'm only showing this just so that you can see what I'm talking about from a visual sense, is that this is showing from left to right varying flow levels through a heat exchanger, and how it begins to pick up more and more of the heat transfer because of turbulence. And that really is the key to good, effective heat transfer in any heat exchanger, especially a boiler where you have a fired combustion chamber. You really need good heat transfer. And this is kind of showing you a little closer up view of, say, this is it being a fire tube here on the left, and this being the water side of a boiler, this being the tube wall. You've got a lot of heat being exposed to that tube wall from the flame side of things, the combustion side of things. And the objective is to get it into the water as quickly as possible. Now, that's not possible with stainless. There's a higher latency there just because of the nature of the material. But if we're flowing water in a turbulent fashion, we can overcome this, boundary layer here and maintain good heat transfer. Well, then the material is going to hold up really well. But if we don't, then of course it will stress it, and it tends to crystallize over time and fracture. So the other thing that you want to bear in mind is glycol levels. I think you know a lot about glycol already, but just make sure that you account for the glycol and the fact that it does hinder heat transfer, and it will tend to actually cause the heat transfer material to maintain that heat longer, which will cause it to stress as well. In systems today, of course, primary, secondary is very common. It's something that everybody knows a lot about. So in the condensing fire tubes, you have the option in most cases to use a fixed speed pump and the capability of using a variable speed pump. Now, with the variable speed pump, most manufacturers are controlling that variable speed pump with the firing rate of the boiler through the control system. If you want my feedback on that, my recommendation is to always use fixed speed pump, because this is all about the heat transfer equation. It's making sure that you maximize the heat transfer and minimize the stresses on that exchanger. The variable speed pump is a great idea. There's certain applications where it makes sense, but typically in a new design, my recommendation is, if you're going primary, secondary, stay with a fixed speed pump. This is a discussion that you can have with your long sales guy. If you have additional questions, we can go deeper into that. Now, variable primary is very common today, and rightfully so. It's very simple. You don't have boiler pumps on there. You do have isolation valves in order to optimize flow going through each one of these if you have multiple boilers. Now, the challenge here is that when you're using a variable speed pumping system, we as a boiler manufacturer and the end user, of course, are dependent on what those pumps are doing and how these isolation valves are being sequenced in order to ensure proper flow through those boilers. And if those boilers aren't flowing optimally, it's very possible that you could be stressing each one of these boilers if the flow rate is too low and these valves are not being sequenced properly. The way that we have addressed that issue is by adding a flow meter to each one of the boilers, so that essentially it's like having a high limit safety on the boiler. Each boiler knows what the flow is going through it and what the requirement is for its respective size in order to operate properly. Most manufacturers today do not have something to control that. So if the flow on the drive on the primary pump begins to drop down, the boilers could suffer greatly for that. And that has been probably the #1 cause of failure, along with reduced heat transfer capability with glycol concentration, probably the #1 cause of failure of a very, very expensive stainless steel boiler. And this is a representation of what happens if fracturing occurs along the fire tube here. Typically, even along this wall on the outside within, this is the fired portion. These are fired tubes. This area right in here is all water backed, so there's a large mass of water. And although there is a large mass of water in there, if there is very little flow going through the boiler, it is going to stress this material out, and over time, sometimes a very short period of time, can cause this to fail. So there are manufacturers that claim, even today, zero flow. Most of the manufacturers that claim zero flow in a stainless steel fire tube have pulled that back and have revised that, but there are still some that do. It is not ideal. I mean, I think the logic here is that, hey, you know, that doesn't make a lot of sense if we're not transferring heat. It's just the logic is no flow, no heat transfer. So that's problematic. So what we have done, again, I mentioned it briefly, to address the issue of flow. Of course, there's a flow switch on all of our units. That's a standard feature. But the other standard feature is that we put an electromagnetic flow meter on the inlet of our X-Burst boiler, because this is a very expensive investment for the customer, and you are designing your equipment and specifying it. They're expecting it to last, but they're expecting that recommendation to be rock solid and for this to be a good investment to them. This unit here is, because of the fact that we include the electromagnetic flow meter along with some additional safeties, including glycol concentration compensation and delta T protection, all designed to protect that exchanger from heat stresses. So one of the things you're going to want to pay attention to is when you're dealing with a manufacturer, be sure to know what the minimum flow rate is. And notice that we've listed this out at minimum flow rate at 100% of firing rate. And that's really, that's very important, but minimum flow rate for ignition and absolute minimum flow. This number here is probably the most important, because if you always maintain this flow rate here, you're safe, because it's 3 times the minimum flow rate, but it'll always ensure that that heat exchanger does not stress out. Now, remember that this is based upon water, though, as a heating medium. So other mediums like glycol and different concentrations of glycol are going to require a higher minimum flow rate. This glycol, right, the glycol concentration, we recognize that there's diminished heat transfer as you increase the glycol concentration. So basically in the programming of our controller, we compensate for that. And that is also dependent on flow as well. So it's both concentration of glycol as well as flow. And as the flow drops, so does the firing rate of the heater, or the maximum firing rate of that heater, again, to prevent heat stresses and to ensure that that heat exchanger lasts for a lifetime. One of the other things that we have in order to ensure proper combustion is O2 trim. And this is something that if you want to know more about, you can talk to one of your long sales guys, but this is an optional feature that is available on the X-Burst. And it's great for altitude. Again, you know, the objective here is to ensure proper combustion, and by ensuring proper combustion, minimizing heat stresses, maximizing efficiencies. Another feature this is remote monitoring. You have the capability of being able to remote monitor, like on an X-Burst. You can actually see what the flow rates are. You can see if you have O2 trim, what the O2 trim is actually doing. Number of different features. And again, if you want to know more about this, a long salesman would be more than happy to discuss it with you. But it is a feature that is standard in the X-Burst. So with that, I conclude by saying that this is the most well-engineered boiler in the universe. You can take it from me. You have my word on it. And actually, I am very proud of this boiler. It's very exciting to see what our engineers have done. And I thank you for taking a little coffee break with me. Cheers.
All right. Thank you very much, Bob. Well, again, I would like to thank everybody for joining this coffee break. Again, thanks again, Bob, for your time. Again, if you do have questions, please contact your long salesperson. And please also join us next week. James Murphy, along with Condair. The topic is humidity and how it relates to the spread of viruses and bacteria control. So a very timely topic. Thanks again, and hope everybody has a great day. Take care.
Thank you.